All right, perfect. So, hello everyone. I'm so excited to be here. My name is Marta Kohmann. For those who don't know me, I'm the Forage Systems Agroecology Extension Specialist here at UW. I've been here for around 1 year, and I appreciate everyone logging in today. So, I'm going to be talking about pasture species mixes for climate resilience. A lot of the concepts that I'm going to talk about have already been addressed by Jason, so I'm going to build up on a lot of the things that he already talked about. So if you've seen my presentations before, you already know this figure that is showing digestibility on the y-axis and the different categories of species of plants, of forages, and how do they fit in terms of that digestibility in terms of the animal requirements on the right of the slide. So again, I just want to emphasize that whenever we're looking at forage options, what we're trying to do is we're trying to match the animal requirements to what forages will offer. So in terms of that, how will that look in terms of animal gain for animals that are grazing forages? So this study here I'm going to talk about is a meta-analysis, which basically is a study of studies. So very similar to what Jason mentioned before, where he compiled a bunch of information from grazing trials in Wisconsin. This also is a grouping results from a lot of grazing studies. So understanding the relationship between nutritive value and herbage mass in terms of animal performance. So this graph here, can you guys see my pointer?
Yes, we can.
Yes, okay, wonderful. So this graph here is showing the average daily gain of animals. This is in metrics, so I marked here the 2-pound mark in terms of herbage mass on the x-axis. And you guys can see 3 different curves, right? So each one of these curves is grouping results from studies with different dry matter digestibility levels. So the upper curve right here is very digestible forage, average digestible forage, and lower digestibility. All right. So basically what this is showing is that the potential to get a high average daily gain is determined by the nutritive value, right? So if you have very high nutritive value, you have the potential to achieve really high weight gain by grazing animals. But whether or not the animals will be able to produce that weight gain will depend on how much available forage we have. So one other way to look at this is that if you have very digestible forage, you also need a little bit less in terms of mass to get the same level of performance. For example, here, digestibility above 600 grams per kilogram, you need a lot less forage than if you have an average digestibility level forage. You need a lot more mass to be offered for the animals in order for them to perform in the same way. And the principle here is basically that if the forages are more digestible, then those nutrients are more available for the animals. So that is really an important part of us looking when we're looking at choosing species for pastures. So more specifically, when we're looking at pastures and resilience over time, especially when we're looking at perennial pastures, what we're looking for is management strategies that are going to allow for long-term persistence, right? That's one of the big goals, not only producing weight gain or milk production, but also making sure that those pastures are going to last for a long time. So Jason already touched on this a little bit, and I'm just going to build up on the concept that he already presented. We know that for forages to regrow, they need growing points in tissue and energy. And that energy is going to come from photosynthesis and stored energy, stored resources that typically come below ground. When I'm thinking about growing points, one of the things that I wanted to bring up is oftentimes legumes and some grasses that have more of an upright growth, they can resent trampling a little bit more than other forages. There's a lot of variation from species to species, and even within species from cultivar or variety to another. That's something to keep in mind. But as Jason already mentioned, residual height is a really important part of grazing management. So we want to make sure that the plants are going to have enough tissue to perform photosynthesis to regrow. So when we're looking at a pasture and we have grazing animals on it, as long as we have enough sunlight, enough water, and nutrients, those plants are going to be able to regrow using photosynthesis. They might repurpose some of those resources below ground to grow a little bit, but mostly they will be able to recover. So that's a good way to go, right? But if we have animals, either we have too many animals or the animals stay for too long in the pasture and they remove a lot of that biomass, they end up relying a lot more on below ground biomass to regrow. And over time, what can happen is, one, there's going to be a decrease in biomass below ground over time, and also just a reduction in biomass above ground. You're going to start seeing a lot of open spaces, which open the chance for weed growth as well. So looking at residual height is a really good way to determine how you're going to manage your pastures. So in terms of nutrients, one of the most important nutrients that we're looking at management in forage systems is nitrogen, right? So when we're looking at grass legume mixtures, one of the things that we need to keep in mind is that these legumes are going to provide nitrogen to the system. So that typically increases the nutritive value, which we already established is a big determinant of how well those animals are going to perform. And also they can increase a lot of biomass as well, because nitrogen just really helps the grasses to grow. In those mixtures, it's really important to care for the legumes. Typically, legumes are a little bit more sensitive to grazing because they have a lot of those growing points above ground. When we're looking at these mixtures of legumes and grasses, it's important to manage soil pH, the stocking strategy to protect those legumes. And one of the challenges for that is also that oftentimes the animals do prefer eating legumes, so they will choose to eat the legume in detriment of the grass. So this study, again, we're looking at average daily gain of 4 different treatments, so tall fescue, meadow fescue, and the same grasses with clover. And again, this is in metric system, but I did mark the 2 pound on the y-axis. And what we see here is that always inclusion of legume did increase average daily gain, and that is very much related to increasing nutritive value. All right, so again, nutritive value and forage mass, they complement each other to determine whether or not your animals are going to perform. Now, again, a lot of these things were already addressed today, but I wanted to again mention the difference between the different management strategies that we have. We can have continuous or rotational grazing. Some of you might know it as stocking, continuous and rotational stocking, or we also have harvested systems. So in continuous grazing, what we see is typically animals will have access to the whole pasture, so they can choose plant parts and plant species within that pasture. And a lot of nutrients are cycled. Between 50 and 70% of nutrients are cycled through urine and dung, which is really important for the health of the system. There can be an increase in nutrient buildup in the soil, so the known hotspots in areas where the animals congregate, or if you're bringing in hay, for example, to the area, the animals congregate there, there can be an increase in nutrient buildup and trampling. So something to keep in mind. As Jason already said, when we have rotational stocking, basically what we're doing is we're reducing the access to the pasture by the animal. So we are allowing the forage to rest in between grazing events. There's typically a greater distribution of nutrients because the animals are circulating through that whole pasture. And again, plants can rest in between grazing events, which is very different from harvested system, where we removed a lot of the nutrients. So it's always important to keep attention to that in terms of nutrient replenishment. And I wanted to mention those two resources for soil fertility guidelines. There's a lot of information there on how and where to sample and how we're going to look at nutrient replacement, as well as the other publication on extending the grazing time as well, which Steve is going to talk about in just a little bit. So generally speaking, what we see is that from harvested to rotational to continuous grazing, there's more selection there's an increasing in selection gradient in those systems. So we are currently looking at another aspect of resilience in pastures, which is weed management. So we have an experiment at Lancaster that is looking at stocking period effect in mixed grass pastures. So this is Arthur. He's our master student. If you see him around, give him a high five. This experiment has been a lot of work. And we're looking at mixtures of grass and legume pastures. And we're basically just looking at differences in stocking period. So we have 1 day stocking and then 32 days of rest, 4 days where the animals have access to the pasture, and then 32 days of rest, and 8 days of stocking with 32 days of rest. We're also using what is called a variable stocking rate strategy, where we put animals or remove animals in accordance with how much biomass is being produced. So that was really important this past year when it was very dry. This experiment was just finished the first year. We're going to do a second year coming up in 2024. So this was done, this whole cycle of grazing and resting was done more or less 3 times this past year, especially because of the drought. We had to end it a little bit earlier. It's a very large area, and we're using beef on dairy heifers. So looking at the weed population, the weed biomass in this study, we first saw absolutely no difference in the beginning of the grazing season. But as the time advanced, leaving animals longer, there was a difference in the amount of biomass of weeds. However, when we look across all of the experiments at the end of the season, the cover was similar across all treatments. And the reason for that is that most of the biomass in terms of weeds were made of dandelions, which are one forage that the animals actually really like. We can get on a whole philosophical discussion about what is a weed, what is a pasture. But one thing to keep in mind when we're looking at weed management is that there are some weeds that are toxic or that have thorns, so they can be affect your pastures negatively. So there's another publication I wanted to mention, which is A4019, Toxic Plants in Midwest Pastures and Forages. So if you are unsure about whether or not you need to do some kind of intervention on your pastures to control weeds, identifying whether or not they are detrimental for your cattle is a very good strategy, very good point to start. We are currently processing the animal and forage data, and as I said, we're repeating this experiment another year. This is really important. We're looking at grazing management because there is a lot of year-to-year variation, and we are very excited. We're going to get that done for another year. Gives me a chance to also say some words of appreciation for the folks at Lancaster who have been really great at helping us manage this experiment. Yeah, thank you for your time. And yeah, my email is here. If you have any questions, I'll be happy to answer them.